Hello there today, how are you doing? Today we'll be going over some different types of solution methods for multi-phase mixtures. Typically in ANSYS we got 3 different solution types for different types of problems that we're going to be facing here, but one note is always use double precision. As you can see here, this is an Eulerian multi-phase mixture. This is because it's a complex system. You got a fluid, which is actually a solid, being represented in a mass that is under gravity and a multitude of other forces. Here we got a multi-phase mixture where you got a miscible solution there, and you got thermal because that milk is nice and ice cold and the coffee is steaming hot, so you got to take into account of that energy there. Here we got one of the simpler fluids, a volume of fluid approach here, which is not too hard, but you still got some things you got to account for here with momentum, mass, and energy. You got really multi-phase mixtures here in the mass, and that's what's being tracked throughout the solution phase. You got a no phase for the alpha, and then you got a phase for the alpha. We'll get into that later. Just it's useful for these types of solutions where you got a slug or a stratified free surface flow, and you can account for things like surface tension with different types that are useful. Here we're actually accounting for surface tension because of the different criteria. With the volume fluids, we got a discretization here. Well, that's a big old mouthful if you know what I mean. Well, sorry about that. In which you have an implicit or an explicit solution method, which you can use the modified HRIC scheme in the theory guide if you want to learn a little bit more. Here's the solution though that we're going to be proposing. We got a nice little push for acceleration case 1, and you can see that. And then for acceleration case 2, we got a big old shove. But here in Minnesota we don't do anything big, so we're just nice and little shove here. So with the setup, there's a lot going on. So here we got the actual setup and the ANSYS Fluent. You got multiple models, implicit and explicit, ran in this solution. I got a primary phase of water, which is red, and I got a secondary phase air, which is blue in the models. What you can see on the bottom right is that representation of the diagram in 2D, and I really upped the nodes to make sure that I was going to solve right because I had some issues initially with the fine default settings. Additionally, I got that wall adhesion settings down there too. And what you see here is the representation or the solution of the 2.5 meters per second case 1. You can see that it represents a little bit pretty similar to what you saw in the actual experimental value, where it's not moving around too much. And what you got here is you got a big old sloshing solution at 5 meters per second. You can see that it's really moving around a fair bit and accounting for that volume of fluid. And you can see that although it's a solution, you got a slight little issue that I had with disk space on the Z drives that we use. So always make sure you have enough disk space, and that can be verified here, where you can see that ppm file being about 2 megs and then goes down to 0 kilobytes, so don't do that. And then you got some other really interesting solutions that you can find online, and that one was quite a doozy there at 14 hours for a solution time. And you betcha this is the end.